Hello. This is about 20 algorithms. That is the shortest list of algorithms in JavaScript that I could find. Algorithms are machines. Their main importance today is to know how to write code. There are not many theories about writing code in computer science. That's what concerns all the rest, all there is algorithms. There is a reference to the PDF used in this video in the description, so you can read it and also run the code directly by clicking on the links, as long as the code remains in the one compiler. There is a function for linear search, so there is really no need to write a loop. Binary search assumes that the array is sorted. In every iteration it looks at the left and right half of the segment. Bubble sort goes repeatedly through the array, each time swapping the elements that follow each other that are in the wrong order. Insertion sort goes through the array and in every iteration moves the value of the current element back where it belongs by the sorting order. Selection sort goes through the array and for every element it finds the element after it that is minimal and then swaps the values of these two elements. Towers of Hanoi is a recursive algorithm. Here the base case is the number n equals 0, from which it starts to return. Every time the disk of some number will be moved from the source road to the auxiliary road, and then from the auxiliary road to the destination road, using the remaining road as the auxiliary road. Depth-first search traverses the graph recursively for each node traversing the adjacent nodes. Here the graph is represented as adjacency list. Fibonacci numbers are numbers in sequence, where every number is sum of the two preceding numbers. The implementation here is recursive. Sudoku algorithm uses backtracking, that is trying solutions. We cannot find all solutions. Safe checks if a number can be placed. The base case is when the end of the board was reached. When reaching the end of the row, it goes to the next row. If the cell contains number, the next cell will be checked. Otherwise it is checked if a number can be placed. M-coloring algorithm is also a backtracking algorithm. Is safe, checks all piles of vertices. The base case is when the end of graph was reached. The recursive case is checking whether a color can be assigned to the vertex. N-queens algorithm is a backtracking algorithm. The board is an array of the row numbers of the queens. The base case is when the end of the board was reached. The recursive case is trying to place a queen to the current column. Catalan numbers algorithm is a typical recursive algorithm. Binomial coefficient algorithm is also a recursive algorithm. Subset sum algorithm is a bottom-up dynamic programming algorithm that uses memoizing. Bottom-up algorithms are iterative. The base case is setting the upper row to true. Array eSum has a row for every sum. When eSum ij is true, this means that there is a subset in array O to j minus 1, the sum of which is equal to I. The array is iterated and in every iteration it is iterated through columns. The prime numbers algorithm uses sieve of Eratosthenes. That is in a way also a form of memoizing. The lowest common multiplier algorithm goes through the array and for each element it calculates a new multiplier. Euclidean algorithm repeatedly replaces one number with a reminder of dividing that number by the other, because then the greatest common divisor doesn't change. The base case is when the reminder is 0, then the other number is the greatest common divisor. Count set bits algorithm counts bits that are 1 in binary number. N and n minus 1 always removes 1, 1. Odd bit strings algorithm adds binary numbers represented as strings. Parity algorithm is the same as count set bits algorithm, except that instead of counting the ones in the binary form, it finds whether there is even or odd number of ones. So I hope that this video was useful for you. So thank you for watching and see you.